Hey everyone, what I'm going to do now is I'm going to go through the same problem using a different approach, just so you have two different ways of actually tackling the problem. Now what I'm going to do this time is I'm actually going to draw a triangle. So based on that information, it's a bit of a shoddy triangle, but it'll do the trick. Okay, so there's our right angle triangle. We've got an angle theta here. And we know that sine theta is the opposite over the hypotenuse. So you've known this identity for quite some time. So the opposite of this angle is over here, and the hypotenuse is this side here. So I can actually use Pythagoras' theorem to figure out what the unknown side is there. C squared equals A squared plus B squared, so 13 squared equals, I'll leave A as it is and then make the B 5. So that's 169 equals A squared plus 25. If we take away 25 on both sides, we're left with 144 equals A squared. So take the square root of both sides and you get A equals 12. So I'm going to just put 12 on that side right there. Now I should specify this is technically a plus or minus 12, but we'll just go with the positive answer for now. So based on this triangle, I can now write that cos theta is the adjacent over the hypotenuse, which is 12 over 13. And only now do I need to consider whether it is positive or negative. So given that it's in the second quadrant, we know that cos in the second quadrant is negative, so I'll just make that negative. And tan theta is the opposite over the adjacent, so that's 5 over 12 in this case. And again, because it's in the second quadrant, I know that tan is negative, so I'll just put a negative in front of that. So it's negative 5/12. Personally, I think that's a much easier approach to a question like this. Obviously worked out nicely because of having a Pythagorean triad, so the numbers are all pretty nice, but yeah, even just looking at the time of this video, seems to have worked out quite well. So anyway, I'll leave it there, but that's everything from exercise 6C. Anyway, I'll see you next time.